In this video, we're going to talk about the factor theorem, and we're going to do an example. So what is the factor theorem? Basically what it says is that, if you have a polynomial, it has a factor, x minus a, if and only if you plug in a into that polynomial, you get 0. Okay, so let's go ahead and try to do that. So let's use the factor theorem to show that the linear polynomial is a factor of the second polynomial. Check the solution using synthetic division. Okay, so we have this, and we're trying to determine if x plus 3 is a factor of this. All right, so first thing, what is our f of x? That would be this big long polynomial here. Okay, so this is equal to f of x. Next thing we need to know is what is a, right? Because what we're going to do is we're going to plug in a for f of x, and we're going to check to see if it's 0. If it is, then we know that x plus 3 is a factor. So what is a? A is whatever the opposite sign of your x, so of this term, of this expression here. So it'll be the opposite sign of 3, so it'll be negative 3. So a equals negative 3. Right, so if you had x minus 3, then a would be positive 3. So it's the opposite sign, that's what I mean. Okay, so what do? We just plug in f negative 3 into f. Right, so we'll have 3 times negative 3 to the 4th plus 9 times negative 3 to the 3rd minus, minus 4 times negative 3 squared minus 9 times negative 3 plus 9. Alright, so now it's just doing this math. So we'll have 3 times negative 3 to the 4th is 81. 81 plus 3 times negative 27 minus 4 times 9 plus 27 plus 9. Okay, that equals 243. Go ahead and check this math yourself. You can pause the video and check it. Minus 243 minus 36 plus 27 plus 9. Okay, these cancel. 27 plus 9 is 36, so that's basically 36, negative 36 plus 36, which is 0. Okay, so f of negative 3 equaled 0. So that proves, using the factor theorem, that x plus 3 is a factor of this polynomial. Alright, so let's go ahead and check our answer using synthetic division. Okay, so now let's do synthetic division. First, let's check that we're not missing any powers of x. 4, 3, 2, 1, 0. Good to go with that. Alright, so now I take all my coefficients. So I'll have 3, 9, negative 4, negative 9, and 9. Alright, then I take the opposite of this, so negative 3 instead of positive 3. Alright, drop the 3, 3. Negative 3 times 3 is negative 9. Negative 9 plus 9 is 0. Go up. Negative 3 times 0 is 0. Negative 4 plus 0 is negative 4. Negative 4 times negative 3 is positive 12. Negative 9 plus 12 is 3. Negative 3 times positive 3 is negative 9. The remainder is 0. All right. So that means that you could write your solution. So if we were trying to divide these two, let me write this out actually, because this is an important point. And previously, when we were talking about synthetic division, we were talking about it with regards to dividing the two polynomials. So, and then we would say, oh, okay, well the answer is this 3x to the 3rd power plus, so this would be x to the 3rd, that'd be x squared, that'd be x, and then that last one would just be a constant. So this term, I don't need to write it because it's 0 times x squared. So So instead of plus, let me write minus 4x plus 3. And then if I had any remainder, I would write that here. In this case, the remainder is just 0, so I could leave that alone. Okay, so I could rewrite this. I could multiply both sides by x plus 3. And what would I would get? I would get 3x to the fourth plus 9x cubed minus 4x squared minus 9x plus 9. If I were to multiply both sides by x plus 3, then it would cancel here, right? So if I were to do this, I'd have x plus 3, and then this times x plus 3. So it would cancel there, so it wouldn't be on the left-hand side. But on the right-hand side over here, I would have 3x third minus 4x plus 3 times x plus 3. Okay, so what you see is that this polynomial has now been factored into these two polynomials. All right, so you see this x plus 3 is indeed a factor of this big long polynomial over to the left. And that's what the factor theorem said.